Fluid measurement is an integral part of process equipment. Having the right amount of gallons of fluid usually determine the quality of the product. Which is why some product taste in a certain way irrespective of where they are produced. Having too much or less liquid addictive can affect the taste, color and smells of the product produce. Flowmeter are usually used to measure fluid in process equipment. So basically, not only that flowmeter is pivotal during blending and mixing activities. It is also an important equipment in a control system. The PLC need the volumetric count in order to determine whether to continue to keep the process valve open or close. Now that we have known its importance in relation to industrial use, let's look at the type of flowmeter we have and their working principle. Mechanical flowmeter is a flowmeter that is used to measure fluid flow through the arrangement of moving parts. At the inlet of the pipe, the water will interact with the turbine. This interaction will make the turbine to begin to spin, as the fluid flow through the flowmeter. The spinning turbine will turn some other gear within the flowmeter. The turning gears will in turn spin a fluid meter and a reading that is in relation to the fluid movement will be gotten. The gears and turbine of the flowmeter are designed in such a way that the fluid measurements is proportional to the gear teeth and the turbine blade. The mechanical flowmeter comes with some drawback. Mechanical flowmeter are not suitable for water that has large particles. This type of fluid can affect the gears and some internal mechanism of the flowmeter. Most time, this type of flowmeter are used with fluid that are free from dirt and particles. A magnetic flowmeter is also known as magmeter. This meter is used to measure the flow of fluid. Unlike the mechanical meter that comes with moving part, this meter does not have any moving part. And with the absence of moving part comes its versatility. This meter can be used to measure liquid that comes with particles and any other dirty liquid. Now let's look at how magmeter work. A voltage signal will be generated when a conductive liquid flows through the magnetic field. The faster the flow of the fluid, the greater the voltage signal generated. The generated signal will be picked by the electrode sensors. This sensor is located on the tube wall. The pickup voltage signal will be sent to the electronic transmitter. The sent signal will be further processed by the transmitter. This process's signal will be sent to the programmable logic controller for further logic processing. Now let's look at Michael Faraday law in relation to how this meter works. The working principle of this meter is based upon Faraday's law. As we all know, the voltage induced across any conductor when it moves at right angles through a magnetic field is proportional to the velocity of that conductor. By the design of this meter, Faraday's law indicates that voltage is dependent on the average liquid velocity, the magnetic field strength and the length of the conductor. This length is the distance between the two electrodes. Vortex meters are essentially frequency meters. This meter measures the frequency of vortices generated by a bluff body or shader bar. The meter has a sensor tab that moves from side to side as the fluid passes through the meter. As we all know, when a moving fluid encounter an obstructions, the fluid will separate and move around the obstruction. In this case, we are using a sensor tab. And at this point of separation, vortices will be formed. The form vortices will be picked up and registered by the moving sensor. The total flow of liquid can be calculated by the number of vortices that is picked up by the sensor. This means, higher liquid flow will result to higher vortices, and lower the liquid flow results to lower vortices. Again, with this technology comes with its own drawback. This meter is not applicable for fluid with particles. Because fluid with particles can prevent the sensor tab from swinging freely. Ultrasonic Flowmeter is another industrial fluid measuring device. This device measures the flow of fluid through the propagation of sound wave. The wave propagation is done through the use of two pairs of sensors. The sensor comes in two configurations: the transmitter and the receiver. The sensor in the ultrasonic flow meter can switch mode. That is, in a certain mode, the sensor can act as a transmitter or as a receiver. Ultrasonic waves travel faster than the speed of audible sound. As we all knows, the audible hearing range for human is between 20 Hz to 20,000 Hz. Why in ultrasonic transmitter, sound range is above the human audible range. So let's look at how it works. When it is in transmitting mode, the transmitter emits sounds wave using the piezoelectric crystals. The generated wave will be transmitted through the flowing fluid. At receiving mode, sound wave coming from the fluid will create a depression on piezoelectric crystals. The depression created will be converted to electrical signals. Now that we have known how it works, let's look at how liquid flow are measured. In fast-moving fluid, it takes a very long time for the propagated wave to reach the transmitting end. While in a slow-moving fluid, the time travel is lesser. Basically, the travel time of the wave has a relation with the velocity of the fluid. The transmitter is designed to work irrespective of the flow direction, which is why the sensor can act as both transmitter and receiver. When the wave is propagated from upstream, that is when the wave moves with the fluid. This tends to aid the wave movement to the receiver, and as such, the wave travel faster through the fluid. While reverse is the case, the propagated wave will take a longer time when it is transmitted against the wave. Because in this mode, the wave will move against the fluid. Furthermore, a simple calculation can be used to determine the fluid distance. Distance equal half and product of speed and sound. The speed is approximately 343 meters per second. Now let's set up an ultrasonic sensor which is aimed at a fluid pipe. The propagated wave took 0.035 seconds for the sound to bounce back. Now the distance between the ultrasonic sensor and the pipe will be 6 meters. Coriolis Flowmeter is one of the most common flowmeter we have in process setup. This flowmeter works on the principle of Gustave Gaspard de Coriolis. Let's look at how Coriolis Flowmeter works. A tube is located inside a Coriolis Flowmeter. An exciter is used to oscillate the tube. The oscillation effect makes the tube to swing to and fro. The swinging happens in sideways directions. When there is no fluid flow, the swing oscillates uniformly. The uniformly swing is measured uniformly by pair of sensor located at the input and output of flow meter. As soon as fluid begins to flow within the tube, additional twisting will be imposed on the tube. Now, due to the Coriolis effect, the inlet shell of the tube and outlet shell of the tube will oscillating in a direction at the same time. The sensor picks up the change in the tube oscillation in terms of time and space. The higher the velocity of the fluid, the greater the deflection of this tube, the higher the volumetric fluid count of the Coriolis Flowmeter. Let's do a quick recap. We started off with the importance of flowmeter. We look at mechanical flowmeter. From there we look at electromagnetic flowmeter, also known as magmeter. We also look at vortex flowmeter. From there we look at ultrasonic flowmeter. Finally we ended off with Coriolis Flowmeter. Hope you have learned something today. See you in the next series.